Okay, question number 7 is this tricky integration question. It wants to appear. And all it's told us is the equation of the line, the curve, which is y equals 3x take away 1 to the power 4, and the fact that this point is a tangent, this line is a tangent line, and p, the coordinate of p, is 116. What we can find quite quickly is this point here, which is when 3x take 1 to the power 4 equals 0, which is when 3x take 1 equals 0, so when x is a third. So that point there's a third. And we also know that if I drop this line down here vertically, that coordinate there must be 1 because of the 1 from p. What we need to find is this point here, because if we know that point there, we can integrate the curve between a third and 1 and then take away the area of this triangle. And if we know the base length of the triangle, we know the height is 16, so we can take away that white shape. So first job, I think, is to find out this coordinate q. Well, what do we know about q? We know q happens when y equals 0 of this tangent line. So we need to find the equation of the tangent. Equation of the tangent, we need to know the gradient of the tangent. So first proper job is to differentiate this 3x take 1 to the power of 4, which is going to be 4 lots of 3x take 1 to the power of 3, but times by 3 as well, using the chain rule. So that's 12 bracket 3x take away 1 cubed. So what's the value of the gradient at p when x equals 1? So when x equals 1, the gradient is 12 lots of 3 times 1 take away 2, so that's 2 cubed. So that's 12 times 8, and 12 eighths are 96. So we know that the gradient of the line is 96, and we know that it goes through the point 116. So we can use y minus y1 equals mx minus x1. And I know this number's pretty massive, but don't worry, it is correct. So we've got that y equals 96x, and minus 96 plus 16 is minus 80. So when does that line go through the x-axis? It goes through the x-axis, as I've already said, when y equals 0. So that's when x is 80 over 96, and 80 over 96 simplifies to 5/6. So that's right, because we know it's between a third and 1, and it looks pretty accurate as well. So that q's coordinate is 5/6, 0. Now we can do the integration, and when we integrate between a third and 1, it will give us the grey bit plus the white bit. So that's my next job. Integrate 3x take 1 to the power of 4 between a third and 1. So that's like section 1 finished. So to integrate this, we're going to add 1 to the power, divide by the new power, but divide by that coefficient as well. So that gives us 3x take 1 to the power of 5 over 15. And we're integrating between 1 and a third. So when we put 1 in, we're going to have 2 to the power of 5 over 15. And when we put a third in, we're going to have 0. Because we're going to have a third of 3, which is 1, and then 1 take away 1. So that is just 2 to the power of 5, and 2 to the power of 5 is 32 over 15. So that is the area of the grey plus the white. We then need to find the area of this white section here, this triangle. We can see that it's got a base width of a 1/6 and a height of 16. So the next job is to write down the area of the triangle, which will be half the base times the height, so that's a half of a 1/6 of 16, which simplifies to 4/3. And therefore, the shaded section that we need is going to be 32/15 take away 4/3. Which comes out at 4/5 or 0.8.